Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. Today's class in our channel we are going to discuss strength of material subject. Okay, and in this subject today's topic is volumetric strain. Okay, so let us start today's class. If you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Okay, so let us start today's class. We are going to discuss volumetric strain. Body subjected to a single force undergoes some changes in its dimensions. Change in volume to the original volume is known as volumetric strain. So summation V is equal to delta V by V. Delta V is change in volume, V is original volume. So change in volume is delta V by V is equal to P by BTE into 1 minus 2 by M. Okay, so now we'll see with this help of this diagram. We'll see this diagram. Just concentrate this diagram. This is the length of the bar. Okay, so this is a rectangular body. You can see this is a rectangular body. This is the P is the tensile force acting on both the sides. P is the tensile force acting on both the sides. L is the length. Okay, B is breadth of the bar, and this T is the thickness of the bar. Okay, now we will see this one. Change in volume is delta V by V is P by BTE into 1 minus 2 by M, where B is the breadth of the bar, T is the thickness of the bar, and E is a modulus of elasticity, P is tensile force acting on the bar, 1 by M is Poisson's ratio. Okay, so volumetric strain of a rectangular body subjected to an axial force is delta V by V is summation into 1 minus 2 by M. Okay, see this one. Okay, volumetric strain of a rectangular body is subjected to three mutually perpendicular forces. Okay, volumetric strain of a rectangular body is subjected to three mutually perpendicular forces. So here we are having the diagram, right? So here in this diagram, first of all we have to plot the three mutually perpendicular forces. Okay, so this is X, right? This is Y, and this is the Z. Okay, X, Y, X, Y, and this is Z. Understood? Okay. Now we will see summation of X is equal to, in X direction, sigma X by E minus sigma Y by ME minus sigma Z by ME. So that is equal to 1 by E into, if you take 1 by E outside, so into sigma X minus sigma Y by M minus sigma Z by M. So now Y direction, summation of Y is equal to sigma Y by E minus sigma X by ME minus sigma Z by ME, that is equal to 1 by E into sigma Y minus sigma X by M minus sigma Z by M. Now Z, sigma summation of Z is equal to sigma Z by E minus sigma X by ME minus sigma Y by ME is equal to 1 by E into sigma Z minus sigma X by M minus sigma Y by M. Okay, so volumetric strain delta V by V is equal to summation of X plus summation of Y plus summation of Z. So tensile, it is positive, compressive means negative. Okay, these point, both the points you have to remember. The tensile, it is positive, compressive means negative. Okay, now we will see this bulk modulus. Bulk modulus body, which is three mutually perpendicular uh, stresses. The ratio of direct stress to the corresponding volumetric strain is known as bulk modulus. So K is the symbol for bulk modulus, is equal to direct stress by volumetric strain is equal to sigma by delta V by V. Now we'll see the relationship between bulk modulus and Young's modulus. K is equal to ME by 3 into M minus 2. Okay, relationship between bulk modulus and Young's modulus is K is equal to ME by 3 into M minus 2. So shear stress. Now we'll see the shear stress. Section, in a section, two equal and opposite forces acting tangentially across the resisting section, as a result of which the body tends to shear off across the section. The stress induced is called shear stress. Okay, the stress induced is called shear stress. Okay, now we are having the diagram. The corresponding strain is called shear strain. So shear stress on a rivet, see, you can see this is the force acting, okay, shear stress on a rivet, right? This is the shear principle of shear stress, okay. It states a shear stress across a plane is always accompanied by a balancing shear stress across the plane and normal to it. Shear modulus or modulus of rigidity within the elastic limit, the shear stress is proportional to the shear strain. Tau is proportional to the, this is phi. So tau is equal to C into phi. So tau by phi is equal to C into or G or N. So tau is shear stress, phi is shear strain. Okay. Now see here. C is a constant known as shear modulus or modulus of rigidity. It is denoted by G or N. Relationship between modulus of elasticity and modulus of rigidity is C is equal to ME by 2 into M plus 1. Okay, these are the formulas you have to remember. Then only we can solve the problems. Now we'll see one problem. Okay. A steel bar 2 meters long, 20 mm wide and 15 mm thick is subjected to a tensile load of 30 kilonewtons. Find the increase in volume if Poisson's ratio is 0.25 and Young's modulus is 200 gigapascal. So each and every class I am saying the same thing. First of all, you have to understand the problem. Okay. So how we can understand the problem? You have to read it once, twice, thrice. Then only you can understand it in a better way. So after understanding the problem, you have to go for the solution. Okay. So here once again I will read this problem. A steel bar, listen carefully. A steel bar 2 meter long, 20 mm wide and 15 mm thick is subjected to a tensile load of 30 kilonewtons. Find the increase in volume if Poisson's ratio is 0.25 and Young's modulus is 200 gigapascals. So we'll start the solution. L is 2 meters, converted 2 into 10 to the power 3 mm. Width is 20 mm. Thickness T is 15 mm. Tensile load P is 30 kilonewtons. 30 we are taking it as 30 into 10 to the power 3 newtons. Poisson's ratio 1 by m is 0.25 or m we can write as 4. Okay, Young's modulus of elasticity is 200 gigapascal, that is 200 into 10 to the power 3 Newton per mm square. So let delta V is equal to increase in volume of the bar. We know that original volume of the bar. Okay, right. See, delta V by V is equal to P by BT into 1 minus 2 by M. This is the formula. So once we put all these values, this is the P value, this is this value. Okay, once we put all these values in this formula, we are getting 0.00025. So delta V is equal to 0.00025 into V, that is this one. So we are getting 150 mm cube. Okay. So next, relationship between bulk modulus and Young's modulus is K is equal to ME by 3 into M minus 2. Okay. So that's all friends for today's class. I think all of you understood today's class. If you are having any doubts regarding this strength of materials, please post in the comments box. I will give you a reply. Okay. If you are not subscribed our channel, please subscribe our channel. We need your most valuable support. Okay. Please like and share our classwork. Okay. So thank you very much. Thank you for watching.